Okay, so we're going to talk about Shiny Part 3 today. We are going to mostly talk about Shiny dashboards today, all right? And then if we have time, I'm going to introduce a few other concepts, okay? So we'll talk about reactivity a little bit, and then I'll sort of introduce the idea of Shiny modules. I'm not really going to talk about them at all, but I'll give you resources to learn more about them if you want to. It's a pretty advanced topic, and so that's more for like way down the road when you're building like really big apps. Then it's worth looking into those. If you're just building little prototype sort of things, I don't think it's worth it. The other thing we will talk about though is some best practices and things that you can do to make your Shiny app a little more clean, so it doesn't blow up into this big thing that is impossible to understand and parse through. Okay, so introduce Shiny dashboards. I'll talk about reactivity a little bit, and then we'll talk about some Shiny best practices. So learning objectives today, hopefully you'll be able to create at least basic Shiny dashboards, and then have at least a basic understanding of reactivity and how Shiny uses reactivity and how you might need to use reactivity when you're working with Shiny. And then recognize use cases for your skills in functional programming that you've built up through this class to help make your app more efficient, more clear, more whatever, okay? So getting started, right here is a link to this getting started thing through our studio, who are the creators of Shiny Dashboard. Some of what I'm gonna cover here is exactly from there. If you want more content beyond what we'll get to today, that's probably a good place to get started. All right. So here is the most basic dashboard that we could possibly have. Okay, so I have to load Shiny, and then I have to load Shiny Dashboard. So loading Shiny Dashboard itself does not give me all the functionality of Shiny. So I have to load both of those. Then I'm going to create a UI and a server, just like before. But within the UI, that's where things are different. Okay, the server is actually exactly identical. And the UI, the main thing that's different is we have this dashboard header instead of the title or whatever. We have a dashboard sidebar, which is one of the most sort of distinguishing features of the dashboard, I would say. And then the dashboard body. And so this is sort of like the main panel in a normal Shiny app. When you run that, it'll look like this. So this is the dashboard header. That's going to be this part, this blue part up here. Okay. The dashboard sidebar is going to be this black part over here. And then, and then the dashboard body is just going to be this part here. Okay. Once you go into the dashboard body, you will also, just like with Flex Dashboard, you will have boxes. Okay, so I'll have a box for some output, maybe another box for some controls or whatever. Okay, so we're going to try this. So what I would like you to do is go ahead and just follow along. So copy this code and then get it going. So we're going to load Shiny and Shiny Dashboard. We're going to say dashboard page. For the dashboard header, we're going to just put a title in there saying this is a basic dashboard. We're going to put a sidebar, but for now, we're not going to do anything there. And then we're in the dashboard body, you're going to put boxes, okay? But the boxes need to be in either fluid row or fluid column. And so in normal Shiny, we were dealing with fluid row, so we'll just stick with that. And then we have box and box, so two boxes. One is the output from plot 1. And the other has a title called controls, and it's a slider input. Okay. For the server, we're just going to create a histogram, and this is base R code again because this is just an example I took from them. But we're going to set a seed. We're going to create some histogram data here by just randomly sampling from 500 observations from a normal distribution, and then we're going to render plot, where we're going to first create the data, right? And then we're going to calculate the histogram of the data, okay? So his data is here. And so we're basically just taking a sequence from 1 to however long the slider is on the input, okay? So 1 to 50, 1 to 100, whatever, however long this thing is, okay? Then we're creating a histogram of the data. From there, you can run it with Shiny App, UI, and Server. Okay, so why don't you go ahead and try that? And while you're doing that, I'm going to see if I can fix this stupid thing again. Okay, so let me actually switch my share to RStudio, and I will run this now, and we'll look at it, and then we can start to build from there. Sorry to spend so much time trying to get this thing to work, but it just drives me crazy when I can't see anybody. Okay, so I'm going to copy this, and then let me switch my actual share. Okay, I'm going to create a new .r file. I'm just going to paste that in, library shiny dashboard. There we go. And then I'm going to come over here. I'm going to copy this, bring it down here. And then finally, I'm going to copy this last part and bring it down here. Okay, now I need to save this thing before I can run it. So I'll save it just to my desktop, and I'll call it temp.var. Doesn't matter. Okay, and then I can run app. And you will see. All right, so it looks like this. So here's our histogram of data, and then we have our controls over here. Okay, so all we've really done here is we've changed the user interface, right? So now we have this sidebar, we have this header part, and then we have this main panel where we have two boxes. This is one box, this is a second box. The first box has the actual plot1 output, the second box has the controls. Okay, any questions on that? All right, so let's go back to the slides. I'm going to keep this like this, come down here a little bit. All right. So the main differences, as I've mentioned now a couple of times, is that we have a dashboard sidebar and a dashboard body. You also have now fluid row and box arguments. Okay, so I think before it's actually fluid page. I can't remember in normal Shiny. Okay, so the sidebar is really one of the defining characteristics of the dashboard, and you define that with you can define a sidebar menu. Okay, so if I look over here, I have my dashboard sidebar, right? But within here, I can do sidebar menu, and then I can create within there like menu items. Okay, and so here's an example of that where I'm going to create a menu item which I'm calling histogram. Okay, so that's the thing that I have before. And then the tab name is going to be histo. Okay, we're going to not worry about that for just a second. But we also have this icon we can specify. Okay, and I believe these are font awesome icons. Let me just make sure. So if you go to font awesome, you can go here. Let's see, not that one, not that one. Chart bar. Let's just look there and see if we can find that. Yes, so there it is, right? This is the icon that I'm going to use. So we could look at all sorts of different things. Maybe we want like a clock. I don't know. All right, so there's a clock, right? So whatever you want, whatever icon you want there, you would just put it like this. So icon equals icon, and then the name of the icon, the font awesome icon. Okay, so here, over here, I can add this in by saying menu item. I'm going to say histogram. So that's going to be the actual name of the thing. Maybe I want to call it chart instead. Okay, and then tab name is actually going to go in the dashboard body later. But for now, we're just going to say histo, whatever. It doesn't matter. And then icon equals icon. And then let's put a clock just to do something different. All right. Yeah. Okay. And so that's going to be one menu item. And then for the second menu item, we're going to say maybe we want to call it the controls. Okay. And tab name is going to be equal to slider or whatever, you can call it anything. Icon equals icon. What do we want for our icon here? Maybe let's look at maybe a gauge or something. Nope, that doesn't work. Maybe control. How about a gamepad? Why not? All right. So then I'll say quote gamepad. Okay. So go ahead and do that. Try to make whatever you want. When I do this, it's going to end up now looking like this. So here on the side, we have chart, and I have a clock, and then controls, and it's this little thing here. Okay. At this point, these things are not linked to anything, so they don't actually do anything, but we can see that we've got them there. Okay. So play around with that for a few minutes. Go ahead and add a sidebar menu and some menu items, and you can switch the names of these things or the icons or whatever. Okay? Give you a minute or so to do that. The other thing that we can do is we can actually add the slider to the sidebar menu. Okay? I'm going to hold off on that for a second because I want to talk about this part first. Okay? Referencing menu items. So in our menu items, we have this tab name, histo, right? And this tab name slider. And at this point, they're not doing anything, right? But what we can do is in the dashboard body down here, we can create a tab items, just like we did to create tabs in normal Shiny, right? But then if we name the tab item, the specific tab item, according to the tab name up here, then it will link to those. Okay, so we're going to do that here. Inside this fluid row, I'm going to say tab items. Okay, and then I'm going to put both of these boxes in there. Okay, so I think that should be both of them. Yep. So I'm going to put both of those in there. Okay, now this is tab items. And so now I'm going to have a tab item, singular, not plural, for each box. Okay, tab item. And now this is where the tab name has to be the same thing as up here, what I specified here. Okay, so I'll say histo here, put a comma, and then this is going to go inside of that. Okay. And I'll have a second tab item, and this is going to be this one. Okay, so I called this slider. So I'll copy that, put it there, comma, add this in parentheses there. Okay, so now I have this tab items, and I have two tab names, histo and slider. Okay, and those are corresponding to these menu items up here, histo and slider. Okay, so I will run that. And now it looks like this. And notice we only have the chart showing up here. And that's because you can see this little blue line. We're on the chart there. Okay, if I click controls now, that'll switch me over to the controls. Okay, does that make sense? Go ahead and give that a try. I'll give you a couple minutes. Okay. Now, let's go ahead and try to put the slider in the sidebar, okay? Because the way that we just had it is pretty less than ideal, right? We have two different tab things on the side, and we can click them, but we don't want to click on one, change the slider, then click on the other one to go back to that thing, right? Instead, we would probably want that slider to just be in the sidebar, all right? The other thing that's a pretty substantial bonus about this is if you put it in anything you put in the sidebar, any of the controls like that you put in the sidebar, they will work across everything. Okay, so you can actually still, within dashboards, you can have multiple pages. As long as you have it in the sidebar, it's going to work across those multiple pages. It'll work across multiple tabs, etc. Okay, so that's pretty nice. Okay, so if we want to do this, there's a couple different ways we can do it. One, we can keep this controls tab, and we can put it down in there. Okay, so I'm going to just take this slider input. I'm going to pull it out of there, and then I'm going to delete this whole tab here because I don't need this anymore, right? So let me make sure I get, yeah, to the right one. And then because of that, I got to also make sure I delete this comma because I don't need that anymore either. Okay. Then I'm going to come up here. I'm going to keep this icon, etc. But I'm just going to put a comma and then I'm going to put the slider right there. Okay. So I'll try that. And then when I run the app, it will look like this. And notice controls now has this little arrow. Okay. So we have a drop down menu. So we can click that and there's our little controls. Okay. So what's nice about this is I could from here now actually add additional controls there, right? So I could say select input, and then we'll call it blah, and then label is equal to blah, blah. And the choices are going to be A, B, C, okay? And that's not going to link to anything, but I just want to show you. So now when I run this, I have my controls here. It has a drop-down menu. When I click it, I get both of the controls. Okay, so I have my slider here, but I also have blah, blah, blah that has ABC. Okay, so this is nice because I might have one set of controls for one plot and maybe a different set of controls for a different plot or table or whatever, right? But again, I might have also this, changing the bin width. I might want that to actually impact the plot and maybe a table and maybe like everything on the page. Okay, so in that case, I might not actually want this thing in a drop down like that. Instead, what I might want is to just pull. I'll keep that in there for now, even though it's not doing anything. I'll keep that there, but then I might want to just, instead of adding another menu item, I can actually just put that slider input into the sidebar like that, okay, into the dashboard sidebar. So notice the dashboard sidebar's here, right? So it starts here, ends there. So I have these sidebar menu items, but then I have just the slider input that's going to come after that. Okay, so I run that, and it now looks like this. So here's our controls. It still drops down, but I want this number of observations to always be there. So it's always going to be there. Okay. Questions on that? I'll give you another minute or so to play around with that and see if things break or if you have questions about why things are working the way they are, etc. Okay, so you can tell, right, that this is super, super, super similar to just normal Shiny, the thing that we've been talking about for a little while now, right? The only real difference is sort of the overall UI, the look and feel of the thing, okay? All right. I've mentioned a couple of times that Shiny apps can become pretty unreadable pretty quickly. And it's because of all of this sort of stuff, right? Like you have, like, look at all of this like cascade of parentheses coming down, right? Like, and so it can get confusing in terms of like which one is referring to which one and etc. Okay, so there are a few things that you can do with this. One of the things that you can do, and I'm illustrating this with Shiny dashboards, but it actually works with Shiny as well, is you can create objects for each piece of the dashboard. Okay, so we have the dashboard header. That's going to generally be pretty straightforward, so we can just leave that there. But we might want to create an entire object that is the sidebar. Okay, and even for the sidebar, we might want to create an object that's the sidebar menu. Okay, so here's an example. I'm going to actually just try to modify this one here to show you what I mean. Okay, so let's call this sidebar menu. Okay, so I'm using underscore instead of you know, this camel case to show that that's like my thing. Okay, so I'm gonna call that sidebar menu. All I'm gonna do is just copy and paste that into there. Okay, so this is my sidebar menu now. We have two items, menu item 1 and menu item 2, and then this one has select input. Okay, so that's my entire sidebar menu. But then when I go to create my sidebar, I'm going to create another object that looks like this. Okay, so I'm going to copy all of this out. But then right here, I'm just going to put my sidebar menu. Okay, so these things kind of build up on top of each other now. The sidebar menu goes into here, and this creates the full sidebar. Okay, then when I get to my actual UI down here, I can just put sidebar, and my UI is now quite a bit more clean. Okay, I can do a similar sort of thing where I can say body, right? And or maybe I want to say, I'd probably, in this case, it's pretty simple, so I probably don't need to do this. But let's say I'll do body tabs, okay? And then I'll take the tab items out of here, and I have to make sure I'm grabbing the right one, okay? And then I could do something like that, right? So these are the tab items for the body tabs. And then for the body, it would be this part, right? Dashboard body, fluid row, and then I can get rid of this. And then in here, I'm just going to put the body tabs. Okay, so this maybe looks a little more complicated in this app because this app is so straightforward. But what's nice about this is then I can work on just the body tabs here, and I don't have to worry about like this huge cascading of parentheses. Okay, so then in my actual UI, I have the dashboard header here, the sidebar, and then the body, and that's it. That's my entire UI. Okay, so my UI is now very simple, but it has these other objects that are feeding into it. Okay, and when I run this app, you can see it actually looks and works exactly like it did before. So I've not done anything to change how the app is actually looking in terms of, or how it's working. But what I have done is I have considerably simplified this actual UI right here, right? And I've sort of isolated the bits of code so that I can work on these things sort of by myself, right? So within the body, I have body tabs here, but maybe I have something else that I'm going to put in there too, maybe a table that goes underneath it or whatever. So I could create another object that's the table up here, table output or whatever, right? And so sort of breaking it apart like this can help you work on the individual pieces of the UI, and then at the end kind of put them all together rather than like having this one thing that has these huge like which parenthesis goes to which, right? Because that, again, like this UI, the one we've been working on, is so simple that maybe it's not worth it in this case. But in many, many cases, you start to get a little more complicated, and then the code just kind of explodes, and then you have 37 parentheses, and you have to track which one is going where. The other thing about this, though, is you'll notice I continually have been sort of rearranging where these parentheses are going. My my general approach is that the end parenthesis should always line up with where that thing starts. And so you should be able to track vertically which one goes to which, right? But it is a challenge generally. Okay. Last thing I'll say on this part is beyond just putting these up above like this, you can also actually put these in their own R file. So maybe you have one R script that basically creates the sidebar, right? And then a second R script that basically creates the body. And then that's where all the objects and things, that intermediary things, live there. Okay? That's one way to do it. Does that make sense? Any questions on that? Okay. So here's an example that is pretty straightforward. I've just created the entire sidebar here. This has a menu item, just one menu item, and then a slider input. And then here's dashboard body, where I've just basically copied that thing. And then when I get to the UI, it's just dashboard header, sidebar body. Okay, so this is an example that's in code, so you or in the slide, so you can reference it a little easier. It's a little less complicated than what we just looked at. Okay, that is generally all I really wanted to cover on dashboards. As I said, it is mostly just a different user interface for Shiny, but it generally works and looks and feels exactly the same as Shiny. Okay, so the whole, select input, slider input, etc., and then the whole server part and how the server and the UI talk to each other, that's all exactly the same. Okay. There are tons at this point, tons and tons of extensions for Shiny. You might want to look into those if you're building something that is beyond just something for you. Okay. This is a repo I just discovered that is pretty comprehensive. There's a lot of repos in here I didn't know about, but it's just a repo that links to other repos that are all Shiny extensions. Okay, so you have stuff for theming, you have stuff for UIs. So here's a dashboard theming one. So well, and then there's all of these, right? So let's look at let's see, there's whatever, it doesn't matter. Let's look at this one. So this one, the dashboard now looks like this, right? There's also, like, I don't know, there's just a ton of stuff that you can explore here. So let's see if there's a picture anywhere of what this is going to end up looking like. I don't know. Oh, there we go. All right. So this is like look and feel stuff, but there's also parts where, let's see. Oh, so for example, one of them I wanted to show you that I think is kind of neat is these loaders, right? So very often with Shiny, you have to wait for the server, the computer, to compute something. And so there's all these packages, like Waiter's the only one I'm really familiar with. But basically what it does is it gives you, rather than just having the little spinny thing, it gives you, a bunch of different options for your wait screens. Okay, so you have these full page ones. So you have this little spinny thing. You could also have something like this. It's more full screen. And here's another one. And every time you push it, you get a different loader. Okay, so this is like not that important, but it's kind of nice to have some alternative. Some of them are kind of fancy. There's also another one that I thought was neat that I saw was, let's see, what was it called? It was like full page or something. Yeah, full page. So this is kind of neat because what you can do, and this is the same guy, what you can do is create your Shiny app so they take the full page of the thing. And so you can have like these landing pages like that and then scroll down. So anyway, lots of extensions, lots of things you can do to make it look not like a normal Shiny app and look like a, fully developed web app. If you move towards something that's actually being used out there, there's a lot of other things that you're going to want to be pretty careful about, specifically the wait time. So we're not going to talk about this too much, but just as an FYI, there's all sorts of problems with Shiny apps being too slow. And it's actually not really a problem with Shiny so much as it is usually the way the Shiny app is being built. And so there's a thing called Shiny Profiler. Let's just see if I can find it real quick. this one. Is this it? This looks different. Hang on, because it's built by RStudio. Shiny profile. Yeah, profiling your Shiny app. This is what I was looking for. So basically, you can have it go through your Shiny app for you, and then it will end up showing you sort of what is taking the longest time to run. Okay. Here's an example of a Shiny app. So here's the Shiny app, right? And they're running it, whatever. But then you get this sort of output down here. Okay, so this is like how long these different pieces of this are taking to run. And so this is really helpful because you end up with, in many cases, the part that you think is taking the longest to load or to run is not actually the part that where the bottleneck is. So it helps you identify where that bottleneck is and then work on that to make it faster. Okay, so that's probably the biggest thing that you'll want to pay attention to if you're having apps that are actually like out there being used by people. You can also do other things to speed them up, like using caching. So that's a fairly new thing. Using caching to maximize performance. So here's some examples, but basically what it's going to do is, like, instead of creating the plots every single time you are switching things, it's going to cache them. So then the next time you go to it, it'll just show the cached version of it, like a saved version of it, basically, rather than trying to recreate it every time. Other things for theming, there is this new thematic package. This is the last thing I'll talk about, but it's pretty neat because you can do things like thematic Shiny. So where's hang on. Yeah, so you get stuff that looks like this, and it's like very little work. All you do is add, so like this is what the thing would look like before, and then this is after. And so it styles all your plots and everything to match the style of your actual Shiny app. Okay, so that's a pretty neat one too that is new that you might want to look into. Okay, so any last questions on that before we move on to a new topic? Okay, I'm going to actually change my share, so I'm just sharing the slides now because I don't think I'll need RStudio for a little while anyway. Okay, so reactivity. What is it? Reactivity is what we've actually been using as we've been writing code to create a Shiny app. All right. It maybe doesn't feel like it because it just feels like we're mostly writing our code. But the thing that makes Shiny apps work the way that they do is reactivity. Okay. So what this means is that we're going to have some input, and then we have this graph of dependencies from there. Okay. When that input changes, all the dependencies after that should change as well. Okay. But importantly, those things should not change until the input changes. Okay. And that sounds like obvious, but it's a very different way of working with our code than the way that Shiny, like the way that Shiny does and the way that we typically work with our code are pretty different in this way. Okay. So your input in a Shiny app is basically just a list-like object, right? You can pull things from it by just using the $ to index to say, give me this thing, and all those things are named based on what you supply through the UI, right? So in this case, I'm creating a UI that has a fluid page, and it has some numeric input, and it's called count, label is number of values, and the value equals 100. So that's where it's going to start. But after writing this code, we're going to have an object called input count, right? Input $ count. And the value it takes will depend on the input that is supplied to it, right? But it's going to start at 100. So if the input changes to 32, then input count will be 32, but it's going to start at 100, and it'll just change based on whatever the UI is passed to it. these are also read only. Okay, so you can't actually modify these inputs in your server part. Okay, so if you in your server said input $count and you tried to define that as something, you'd get an error. It wouldn't work. Okay. So it has to be in a it also has to be in a reactive context. Okay, so we saw some examples of this earlier when we first introduced Shiny, but this is why this code doesn't work. Okay, I have server, I'm defining my server here, and I'm saying print paste 0, the value of input count is, and then I try to put input count, and it won't give me anything. Now before, when we did this, we actually had render plot around this, and so we were able to run our app, but it just didn't give us the results we would have expected. In this case, we don't have anything like that. We don't have render text, we don't have render plot, we don't have anything. And so we're actually getting an error. Okay, so this code will not run at all when we call this. Okay, and it's because this input count right here is not in a reactive context. Okay, so when you call render text or you call render plot or whatever, that's taking the thing that is in there and it's putting it in a reactive context. Okay, that probably still doesn't make a lot of sense, but I'll get to that here in just a second. Okay, so the output object is similar to the input in terms of it is just like a list, right? It's a list-like object where you can refer to that thing using the $ or whatever. So you can create new components for the list, of the list for new output. So you say output $ and say some new thing, and then you're going to define that through your server. That creates new elements to the list, and then you refer to them in the UI. But these also need to be in reactive context. Okay, so in the server and in the UI, we need to make sure that those are in reactive contexts. Okay, so that's why we have in the server, we would have like render plot, right? And then, or no, it would be plot out, yeah, render plot. And then in the UI, we would have plot output. Okay, so here's a simple example, right, where we have, hang on just a second, where we have some text input that has a name, and then it says, what's your name? Okay, our text output is our greeting. Okay, greeting is down here. So we have output, which is a list-like object, and we're creating basically a new element to that list, which we're calling greeting. Okay, then we call render text. So that's putting it in a reactive context. And then we can say paste 0, hello, and then input name, exclamation point. And that's just going to put those things together. Okay, so what I'd like you to do now is, so after this, you're going to have to say, Shiny app UI server. But what I'd like you to do is go ahead and copy this code, run this, and then actually play around with it for a second. Okay, and specifically, I want you to notice how it updates. So type your name, but type it slowly and watch how it updates. Okay, I'll give you a minute and then I'll demonstrate. Okay, so here I have just copied this code over, right? So this is exactly the same as we have here. And then we just have this Shiny app part, UI server. Okay, so I'm calling the Shiny app with the UI up here, this UI, and this server. When I call run app on this, and I open it in the browser, notice right now it's set with nothing. Okay, as I type D, it updates. Okay, so it's updating reactively. As I add things to it, it updates. But importantly, it does not update until something changes. Okay, so every time something changes, it will update, but it doesn't update until something changes. Okay, so this is a very simple example, but I think it can help understanding how reactivity is working. let's keep talking about it though. Okay. You don't have, when you're doing this, right, it's gonna like sort of watch that thing and wait for it to update. And so it's not like you have to click a button that says run this code each time, right? Normally when we're working interactively with R, we would hit, you know, command enter or whatever, and it would actually run the code for us every time we do that. But it's not going to run the code until we tell it to run the code, right? Your Shiny app is different. It's going to be like basically watching something, and it's going to update as that happens. Unless you tell it to not do that, because there are ways you can write the code where it says wait for all this input to be put in and then only run after you hit calculate or whatever, right? So you can do that too. But this is an important distinction because your app provides instructions to R. Okay, so this is again a very different way of working with R than we have before. So your app has a set of instructions that you're giving it, and then it's going to decide when it actually runs the code, not you. Okay, it's going to decide that based on your instructions. So this is overall, this is sort of an aside, but this is what's known as declarative programming. And it's declarative programming is sort of across programming languages, right? There's different versions of it across different languages. Normal R code, the way that we typically work with it, is called imperative programming. Okay, so you decide when it's run. With declarative programming, you provide instructions, but you don't actually run it. Okay, so I like this quote from Hadley from the Mastering R book. He says, you describe your overall goals, and the software figures out how to achieve them. Okay, so that's basically what's happening with a Shiny app. Rather than running, like writing some code and running it, you sort of provide an architecture of the software to say, this is what I want you to do, and then it figures out how to actually run that. Reactive graphs are typically shown like this. A lot of this that I'm showing right now too is kind of background information. I'm going to get to in just a minute more sort of how and why. Okay, but when we're thinking about an R Shiny app, okay, normally we would think about understanding code by just kind of starting at the top of the script and working through it line by line until we get to the bottom, right? That's because that's an imperative programming approach. But in this case, with a Shiny app, we can't do that, right? We can't run this stuff line by line and understand what it's doing because it's going to be inserting things and whatever, right? We have the input and the output and the render text or render whatever. And so we can't actually do that. Instead, what we need to do is have a graph. Okay, so this is an example of the Shiny app that we just created, right? We have an input, which is name, okay, and that's going to go into the greeting that we have. And this is a graph, right? So greeting is going to be basically sitting there and waiting. And then name is going to be updated. That's going to feed into the greeting, and then it's going to change. Okay, and that's the entire structure basically of this app because it's very simple. You can create these graphs like this for any Shiny app, which can often help you understand your own Shiny app better. Hadley recommends in the book, and I think this is a good recommendation, but it's hard if you're not used to these kind of apps or this sort of an approach generally. He recommends actually trying to sketch out a graph of your Shiny app and then build it, right? So it might be worth trying to sketch a graph of a Shiny app you've already created, right? Or how you want that app to change. But there's also this React log, which will kind of do it for you. Okay, so this is, again, by RStudio, so it's pretty stable and works well. But it basically works like this, right? Like this is a big Shiny app, and you can sort of step through the whole thing and see where all the inputs are, where the dependencies are, and how all of that sort of changes. Okay, and so this can help you understand your own app, and it can help you sort of understand how the apps are working generally if you want to dig into that more. Here's a really basic example. This is using that function. Okay, so I'll just go ahead and run this, copy it over here, and just get rid of all that. Okay, so I have Shiny and React log, and then I say React log enable. Okay, then I actually run the app. Okay, and then I'm going to close the app, and then we'll run this function, and then that'll actually bring up the graph. Okay, so I'll say run app, and oh, something didn't work. App.r not turn shiny. Okay, maybe I did this wrong. Let me look at this. So this is more about this part. What I'm trying to get to is, well, for some reason that didn't work. I'm not sure why. Okay. And now, there, it worked that time. Okay, so this is what it's going to look like. Okay, so you can see it starts with nothing, and then I can hit play, and you can kind of see, oh, the input changed. It's D now. Okay, so then that's going to go ahead and get passed to the output, and then now A is there, right? And then N-I-E-L. Okay, so this is such a simple app that it's not really terrifically helpful. You just see an input going to one output. Okay, but it does tell you a few things, and you can kind of step through it here. So that might be worth looking at to better understand your own app and to understand how apps are working. Okay, but now let's sort of go back to reactivity for a minute. Okay, so we've talked about sort of what reactivity is a little bit in terms of Shiny, but what is it actually, and why is it helpful? Why do we need it? Okay, so let's imagine for a second that we have an app where we want to just convert from Fahrenheit to Celsius. Okay, so we could do this with variables in R, right? So here I'm saying temp F, so the temperature in Fahrenheit is 72. So the temp in Celsius is going to be this formula. And so I subtract it by 32 and multiply it by 5/9. And so the temp C is 22.2222. Okay, cool. That's great. But in this case now, if I change temp F, right, it's going to have no impact on temp C. They're not related at all. They're not interactive. So I change temp F here to 50, and I print temp C, and it's still the exact same thing as it was before. So I would basically have to change this and then rerun that. Okay, so you might immediately be thinking, well, why don't we change it into a function then? And that's a good idea. Let's change it into a function. Okay, so now I've created a function here, which I'm calling toCelsius, and it just takes my temp F, which is in the global environment somewhere, and it applies that transformation. Okay, so I say toCelsius, I get 10. I change temp F to 30, and when I do toCelsius, I get negative 1.11. Okay, so that's basically working. That's what we want it to be, right? Every time I change temp F, I can rerun toCelsius, and I get the output. The problem is, if temp F doesn't change, I still have to run toCelsius. Like all of that code still has to run in order to get that output. So every time I'm calling toCelsius, even if temp F has not changed, it's going to rerun the code. Okay, and so that is not a big deal for many use cases like this one. This is such a tiny calculation that nobody would ever know the difference, whether that calculation is happening every single time or only when temp F is updated. But in many situations, I just talked about how Shiny apps can be slow. Well, if you're recalculating something every single time, it's going to be extra slow. Okay, So that's what reactivity is about. It's about essentially trying to find a way to avoid this problem. So the calculations are only done when the input changes. Otherwise, it just outputs what it was before. Okay, so not a big deal in this case, but very often is. Instead, what we can do is we can create a reactive variable. Okay, so this is new-ish to Shiny, but if you do library Shiny and you run this code, reactive console true, then you can actually work with reactive variables right in your R console. Okay, so first I'm going to create a reactive variable, which I'm calling tempf, and I'm setting it at 72. Okay, when I call tempf, it spits out 72. Now I can change tempf to 50, and when I call tempf, it spits out 50. So this is just like any other variable in terms of we can redefine it, and it's now that thing, right? There's nothing different about this tempf than there was the previous tempf, except that it now has these parentheses, and we redefine it by passing the number to the parentheses instead of, with an assignment operator. Then we can create a function just like we did before, but we're going to create the function slightly differently. All right. So what we're going to do, now my little kitten is looking like he's going to attack the big cat again. So what I'm going to do is I'm passing this message that says converting. Okay, so this message is only going to be run when this function is run, right? And so here I call tempf my reactive variable, and then the rest is the same. And now it should, if I did this right, it should only print this message when it's actually doing the conversion. So if tempf changes, then it's going to run this code in here, and it's going to print this message converting. And otherwise, it's just going to give you back the new variable, or what it was last time, basically. Okay, so here's 2 Celsius. It says 10. 2 Celsius, 10. Oh, I must have had message set to false here. Shoot. Let's do this. Let me go back here because I want to show you this. I think it's fairly important. Okay, so I'm gonna copy this, switch my share again. Okay, so let me go session, restart R, clear all this, library Shiny, reactive console true, and then tempf is going to be a reactive variable that's 72. Okay, so I call tempf, it's 72. All right, now my function looks like this. Okay, and now I'll call 2 Celsius. And notice I get this message converting 22.222. If I run it again, I don't get that message, okay? Because it's the input, this reactive variable, has not changed. So therefore, the output from that function should not change, okay? If instead now I change tempf and I make it 50, then temp Celsius is going to give me that converting message. But as I run 2 Celsius again and again, it's not converting. Okay, it's not actually doing that operation except when this reactive variable changes. Okay, does that make sense? Do you understand why that can be really important in terms of computational efficiency?
I have a question. How does it know that you haven't updated it? Do you know what I mean?
Yeah, it's because it's this reactive variable. And so basically this function is also reactive. And so this function knows it has this tempf variable. So it's going to basically watch that reactive variable, and it's going to see if that thing has changed since before it runs, right? If it has changed, it will convert it, otherwise it will not. And so
gotcha.
That's sort of like the heart of reactive programming.
That's interesting to me that doesn't take time to like watch it, but Yeah. What do I know? That's interesting.
Yeah. I think it does take a tiny bit of computational power, but it's like minuscule compared to actually rerunning the entire code.
Yeah, that makes sense.
Okay. So unless the value of temp f changes, the code will not be rerun. So that's good. That's what we want. Okay, so that is basically reactive programming. The main thing I want you to think about is sort of why we would use reactive programming, and then also realize that that is how Shiny runs. Everything that you do in Shiny is going to be that way. Okay, so that's why everything in the server has to be wrapped in render something. Okay, and everything in the UI has to be wrapped in whatever output. Okay, and it's because of this sort of interactivity and reactiveness. Okay, there are also other situations. I thought I had an example in here, but I guess I don't. There are other examples where you might sort of expect your code to work, but it doesn't work because it's not in a reactive context. And you can actually wrap things in reactive, just like we did with that function back there. I realize I'm not sharing my screen anymore, but just like this, right? You can actually wrap things in that reactive part to sort of build your own reactivity. So one sort of common example is selecting, like, let's say you have, you want to select variables from a data frame, right? You could have the data bracket empty for the first indicator. So you're going to say all rows, comma, and then you want to be able to select a specific column. So you do input $ call, right? Or whatever. But that won't actually work unless you put it in a reactive context like this, because then it will be able to watch that input thing. So, okay. So that's reactivity in a nutshell. I know it's fast. It's not like super critical that you have a deep understanding of it, but I do want you to be aware that that's what Shiny apps are doing. And so it's a very sort of different way of approaching this than normal R code. Okay, so that's why a lot of it will probably feel a little different as we're going, and it can be harder to debug things sometimes too, because it's not like purely interactive. Okay. All right, moving on to just a couple of Shiny best practices. Okay, this is another quote from the Mastering R book by Martin Fowler. Any fool can write code that a computer can understand. Good programmers write code that humans can understand. I think this is a little bit underappreciated generally, especially I would say within like the scientific communities. There's very much a culture of, if the code runs and it works, then it's good. And that is true to an extent, but like if you're publishing a paper and you want to share the code that you have used, right? Then you probably want to do more than just it works for me, so therefore it's good, right? So trying to write code that's easier for other people to understand is also really important. Okay, so just a couple things to consider. Are the variables and functions names that you're using clear and concise? Okay, so that's just like any of the functional programming stuff that we've talked about. Try to make your names of functions really clear. For functions in particular, I would use verbs as much as possible. Okay, and is the code commented where needed? This is something I am terrible at. We'll just be totally honest. I don't comment my code hardly at all, but in some cases, it can be very helpful to just include teeny little comments. Okay, and this is also sort of difficult because there's like a balancing point where you don't want just tons of comments throughout all your code. But if there's something where you're like, okay, this is confusing, and I know it's confusing, then just put a little comment on there sort of explaining what you're doing. And that's good not just for other people, but for you when you come back later, because if it's written in a way that it would be confusing to other people, it's probably also going to be confusing to you when you come back 6 months later. Okay. Always, I think, pretty much consider if there's a way to break up complex things. Okay, so that doesn't have to always be functions. It generally is functions. So if your function is more than like 30 or 40 lines, then there's probably ways that you can break it up. Okay, for almost for sure, if you're getting over 100 lines, then you can break that function up. So consider doing that. It doesn't, like, there's also with all of this is, you know, like a balance. Like, you don't want to spend all your time refactoring code either. So there is a certain point where it's like, okay, this is good enough, and I'm just going to move on, right? Do you have lots of instances of copy pasting? Okay, if so, consider writing a function and maybe even looping too, depending on what you're doing. Okay, and then the other part of this that we've sort of talked about some, but we'll talk about a little bit more, is are there sort of different components of my app that I can pull out and manage independently? Okay, so that's where I was only focusing on the UI, but when I was saying, okay, let's take the sidebar out, and then maybe from there, we're even going to take the menu items out, and we're going to create new objects that are just those things. So then for that specific object, all I have to do is focus on that thing. When I'm running my Shiny app, if I'm getting an error in that spot, then I can just go to that specific object and work on it, and I don't have to try to work through the entire UI, which might be pretty large. Okay, and if they're too tangled together, then sort of think about ways that you can sort of break them apart. Okay. Functions. So something new I learned as I was putting these together is I talked about before sourcing files, right? You can do that for sure, but you can also just create an R folder in your current directory, and it will source all the R files from there for you. Okay, so let me see. I think I have an example of that. Yes. Okay, so this is, I think, the same app that we had kind of worked with before. So it's app.r, Old Faithful, Geyser. I don't remember what's in there. This is maybe a little bit. Oh yeah, okay. So I have in here now, I have an R folder. Okay, and it's just called R. This is actually the same way that you include R code in packages. And so Shiny now, I don't know if it's new, but I didn't know about it before, will source these functions for you. Okay, so I have funds, which is here, xfaithful, right? This create bin table one we talked about. And then packages here, which is all the packages that I'm loading, right? And I think it's kind of nice to just have a R script for just your packages. And then in your app right here, I have all of this stuff, right? And so you can see I don't have anywhere in here where I'm actually loading libraries. I don't have anywhere in here where I'm referring to that function. But if I come down here to my server, you can see create bin table is right there, right? And that function lives in this funds.r. When I run this, then you can see it all works as we would expect it to. Right, and here's the table. Because I've put those .r scripts in this R folder, and so it just automatically sources them. Okay, so that's really nice and something new that I learned. So you can do that, but here's an example of like how we might consider using a function actually in the UI rather than the server. Okay. So imagine we have a bunch of different slider outputs. Okay, so here's where it's saying fluid row, and notice these slider outputs are basically the same across all of these, right? The only thing that's really changing here is this part, and those are the same. Okay, so can you think of something we might do here to reduce the repetitiveness?
Maybe use map.
You could use map. Yep. I would say I would probably start with a function. Okay. This is still repetitive, but it's less repetitive. So I have a function, I'm just saying ID, and then it's going to be ID, ID. And so this slider input, all of this is just the same as it was before. It's just going to insert the ID into those things. Then I can create my fluid row like this, and I just say my slider. And then I'm just changing this part. So that's less repetitive. But as Chris mentioned, we could also loop through those. So now we can just create an IDs thing, which is alpha, beta, gamma, delta. And then we're going to map through the IDs and use my slider. And then when we call the UI, we'll just say fluid row on the sliders. Okay, and that'll give you, 4 sliders that all have this sort of a body, and the ID and the label are going to change according to these things. Okay, you could also make this function a little more complicated. So you could have this ID and then say comma label, and then over here, maybe you loop through IDs and labels so you could change each of them. So maybe alpha is going to be like capital alpha, or maybe it's the actual symbol alpha. Maybe you could figure out a way to do that. I don't know how to do that off the top of my head, but does that make sense though? So like, let me again sort of do this real quick. Let me go to this one. Okay, so I'm gonna actually just copy this. Let me switch my share over here. Okay, so I'll get rid of this React log stuff. And then I'll go there. I'm gonna get rid of this though. And then I'm gonna copy this one. Okay, IDs, sliders, UI sliders. Okay, cool. And then I'll just get rid of this server stuff right now. Okay, so basically, I just want to show you what this UI would end up looking like, right? Oh, I need to say per map. And then it ends up looking like this, right? So we just have 4 different sliders. Okay, and then as I was mentioning, we could make this a little bit more complicated. So maybe over here we want to say ID label, and then we could switch this to label. And then maybe for the labels, we just want to say paste 0, select whatever, and then we'll just say IDs. Okay, so IDs looks like that, and then labels is going to look like this. So it's select alpha, select beta, select gamma, whatever. That's obviously a super simple one, but now when we get here, we would say map through the IDs and the labels and apply the function mySlider. Okay, and when we run that, we will get it like this: select alpha, select beta, select gamma. Okay, so that's one way that we can make things a little bit more sort of straightforward, or at least less code. Other things we might do, there might be cases where we're doing a bunch of things and we just want to swap the icon, right? And so everything is staying the same, but we have a different icon. So we could write a function for that. We could loop through a set of icons, etc. And then, whatever, anytime you have something where you have like some baseline thing and there's only maybe 1 to 3 different things that you want to actually change in there, then you might consider writing a function, because that might make it less code and potentially more readable, depending on what you're doing. And then I sort of mentioned this before, but I think server functions, I think it's really commonly worth writing functions for the server, even if those functions are not used like super repetitively. So that one I had for creating the table is just kind of a lot of code. And so it's easier to sort of put that in its own file, write a function for that just takes an input, right? And then in my server part, I'm just calling that function rather than having all the code that represents that function. Okay. All right, we're basically out of time, but Shiny modules, they're basically a way to detangle your code, specifically when you need to detangle it in ways that work with UI and the server. Okay, so here's a real quick example where this is like a big complicated app, and this is without modules. And then if you have modules, then you have this part, this part, this part, and then a part down here. Okay, so this is all from Mastering Shiny. But so then you're able to sort of work on each of those modules each time. And notice each of these have sort of an input and server component to them. All right, so that's why modules exist. But they're quite a bit more complicated. So unless your app is getting really complicated, I wouldn't worry about it. here's a chapter on the topic in mastering Shiny. Shiny is really, really very flexible and powerful. Okay, so next time we'll review some of this Shiny stuff, and then we'll review functions and looping. It'll be just sort of an overall review. We don't have class next Monday because of holiday. Can't remember which one right now. Memorial Day. And so Wednesday of next week will be our final class, and I will introduce package development there, but it's going to be just a basic introduction. Okay, so if you have interest in developing a package, you should be able to get started there, and then you can get in touch with me after the class if you want to go further. Okay, because there's a bunch of other topics from that. Okay, so I went 2 minutes over. I apologize. But thank you all, and I will see you on Wednesday.